Sorry, Ireland, I forgot to record the other one.
She's not here. She specifically asked me to record it. All right, so we're going to combine chain rule and product rule. Or it could be quotient. X squared times the square root of 1 minus x squared. All right, does everybody see two different functions there being multiplied together? There's the x squared times the root thing, okay? First of all, do we like roots when we're doing derivatives? No, so what do we rewrite it as? Yes, to the power of a half. So that's our first step. Get rid of any square roots or cube roots or whatever you have. It's a good question. There you go. Okay, first step one, get rid of any square roots. If it's a cube root, turn it into a third, whatever. It's a fourth root, turn it into 1/4. Get rid of those. Now we got to do what rule? What two rules are we going to use here? Product and chain. Okay, so we're going to use product. So f prime. So we do the derivative of x squared. What's the derivative of x squared? 2x. Times the other function, which is 1 minus x squared, to the power of a half. That's the first part of product rule. Plus, what's the second half of product rule say? So the derivative of the other function times x squared, right? So now we have to do the derivative of this thing. Now, if I just gave you that on its own, what rule would you have to use? Chain rule. So let's just do that. The derivative of 1 minus x squared to the power of a half. What do I do first? Drop the 1/2 down. And then what do I do to the power? You take 1 away, so it becomes negative 1/2, right? Am I done? What do I have to do now? By what, sorry? Derivative of the inside, which is negative 2x. Am I done? No, because all of this is just, if I call this g of x, that's g primed. So the other thing I have to multiply by is the x squared. Calculus is over at this point. Okay? That's all the calculus. Now it's the algebra to simplify it, because that is ugly. Okay? It's not too bad. You like that? Just leave it like that. We can make it look better. Okay. So I can't do anything with this bit here. So I'm just going to rewrite that for now. Is there anything I can do with the second bit? What can I cancel or simplify or what? Okay, don't do that, because that's going to make it way worse before it gets better. But this 1/2 here and this 2 here should cancel, right? Because they're all being multiplied together. Does everybody agree with that? Okay, what's x times x? X cubed. And then you have a negative there. So it should turn into negative x cubed into that. That looks better. We don't have a fraction. Everybody good? Okay, now we're gonna do a little side note here. Okay. So we'll do it in whatever this color is. All right. If you think back to math 10 or 11, whenever you do tons of factoring, and I gave you x cubed plus x squared plus x to the power of 1, and I'm writing to the power of 1 on purpose. And I asked you to factor something out of there. What would you factor out? Just an x. And so you'd write it like this. Turn into that, right? Okay. Same principle applies here. Whenever you're factoring something out, you always factor out the biggest exponent or the smallest exponent. You always take the smallest exponent out, right? So when you're doing this, is there a common factor in there? There's x, there's two of them actually. There's an x, right? Okay, so we can take an x out. What about this? Those are the same thing, right? Look at the exponents. Which is the smaller exponent? Negative 1/2. I'll show you. So what you do is we're going to take an x out. So an x comes out as the, let's take the x out first. We'll do that one because I think most people can do that one. If I take just the x out, I'm left with 2 times 1 minus x squared to the power of 1/2 minus x squared. There, I just took an x out in that one, okay? I didn't take out the 1/2 thing yet. I'm gonna do that in this step. So I just took an x out. Is everybody okay with that? Okay, now I see that the 1 minus x squared to the power of 1/2 and 1 minus x squared to the power of negative 1/2, there's a common factor in there of, and you take out the smallest exponent. So I'm going to take out a 1 minus x squared, the negative 1/2 comes outside the brackets. So I get now this is where you just have to think a little bit about what you did in math 10 and 11. When I take this x out here, okay, what did I do to the exponents to get the new exponents? You subtract the exponents, right? So I took out an x to the power of 1, and I went 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0, which is, if your exponent's 0, it's always 1, right? You do the same thing here. You subtract the exponents. So now it looks like it's complicated because it's fractions. These are all rigged to work out. Okay, so if I just go over to the side here and I go 1/2 minus negative 1/2, because that's the exponent I took out, that one. All right, what's 1/2 minus negative 1/2? 1. So I'm left with 2, 1 minus x squared to the power of 1/2, or to the power of 1, sorry. Minus x squared. What about this one? That's what I took out, right? So that's sitting out there, so it's just a 1 there. Does that make sense? We did, so, but you have to subtract the exponents, so it's 1/2 minus this thing here. So it turns into a whole number. So that's what I'm left with in the brackets. And if it doesn't make sense, just check it. Multiply it back in. If I put this, put it back into here, this times this, you essentially add the exponents. What's 1 minus 1/2? 1/2. This times this, Give me that expression. Right? Does that make sense? Okay. This is to the power of 1, so I can now put the 2 into those brackets. So if I dump the 2 in, and then you can collect your like terms in there. So this is correct. Can anybody see any other way I could just make that a little bit better? Not quite. You put the 1 minus x squared to the denominator because it's a negative exponent. But that is correct, but you could write it like this. Okay. You will not see a question that is that complex on your test. Okay. Usually we practice this for like 3 days. Okay. Because they get tricky. All right. So the whole point is, first of all, recognize it's going to be a product rule question. And then within the product, you're going to have to use chain. When you get something that looks like this bit, you always factor out the smallest exponent, which is usually going to be the negative exponent. Okay. And then just simplify from there. I'm only going to ask you to do one question. Page 136, number 25. It's basically the same. It's a very similar question. 136, numbers 25. If you want more of a challenge, you can do 27. But 25. And then that'll take us to break. On the other side of break, we're just doing curve sketching until 3:20. Let's make it 2. All right, so asymptotes. We've already talked about them when we did limits, so for verticals. That's good. What's a vertical asymptote? How do you know if you have a vertical asymptote? Sorry. There's a dotted line on the graph. Yes. How do you know from looking at the equation? So if I give you the equation, f of x is equal to x plus 1 over x minus 2. How do you know if there's a vertical asymptote? Why? Yes, it's what makes the denominator 0, right? So you'd have a vertical asymptote at x is equal to 2. The actual definition, you don't have to know this, I'm just going to give it to you, of a vertical asymptote is the limit as x goes to c, some constant, of your function equals positive or negative infinity, which means you're dividing by 0. Okay, that's what it means. I.e., you're dividing by 0. Okay, so you can see here, if you put a 2 in, you're dividing by 0. It's going to positive or negative infinity. That is the definition of a vertical asymptote. All right, you know that from math 12. That's when we did it, right? Okay, horizontal asymptotes. So we learned those 3 rules in math 12. you remember the rules? Does anybody remember the rules to figure out horizontal asymptotes? I'm going to write them out quickly, and then I'm going to give you the actual definition. All right? I don't care how you do it. I don't think Torsten's going to care either. So, horizontal asymptote. The Math 12 rules were, first one, if the numerator degree is greater than the denominator, then you have no HA. I'm using HA for horizontal asymptote. So that is something like this. X cubed plus 1 over x. No horizontal asymptote. The second rule was if the degrees of the numerator and the denominator are the same, so I'm writing num and denom now. All right. So the degree of the numerator equals the degree of the denominator. Your HA is the leading coefficients. So for example, if you have that, 3x squared plus x over 2x squared, the degree of the top is 2. The degree of the bottom is 2. So you just look at the leading coefficients. So what's the horizontal asymptote? Sorry? 3 over 2. And we would say it's y is equal to 3 over 2. Yeah, that's the degree. It's always the highest power. And the third one is if the bottom, the numerator, has a greater degree. Sorry, the denominator has a greater degree. Then your horizontal asymptote is y is equal to 0. So for example, (3x plus 1 over x squared) has a HA of y is equal to 0. Those are the 3 rules you learned. Okay. The reason those rules work is because a horizontal asymptote has this definition. The limit as x goes to plus or minus infinity equals some constant. So the limit, to figure out the horizontal asymptote, you look at what the function does as your x values get really, really big or really, really small. Okay? And if you don't know what to do and you forget all the rules, all you have to do is plug in a massive number into your function. Okay? Like 1,000,000 if you want it. All right? If you put 1,000,000 into this function, actually put 1,000,000 into this function, all right? 3 times 1,000,000 is 3,000,000 plus 1 is 3,000,001. What's 1,000,000 squared? I don't know what that is. But if you went on your calculator and you went 3,000,001 divided by 1,000,000 squared, you're going to get 0.000000000 something. Okay? Are you doing it right now, Julie? It's going to be a really small number. Okay? And what the reason is, if you're, do a quick Here's a quick lesson on adding infinities. If you're adding infinities, do you care about constants? If you have $1 billion and somebody offers you $1 more, do you even care? I know some people are going to shake their head and go, yeah. But you don't really care because $1 billion and $1 billion in one makes no difference, okay? So when you're dealing with these things like this here, if I say the limit as x goes to infinity of 3x plus 1 over x squared, I don't care if you're about constants when you're adding or subtracting them. So you essentially just go whatever. Okay, you ignore the constant. And it's going to be the same answer as this. Now, if I put infinity into this, which is bigger, the top or the bottom? The bottom, right? And if you're dividing by a really, really big number, what are you getting closer to? You're getting closer to 0. Okay? So this would just give you 0. All right? You can just remember these rules. Okay, no, you won't need to know them for the test. Well, for the test, I'll have to look at the question. But if you know these rules, you can do the question on the test. Okay? But we're going to practice this right now. All right? And we're just going to practice curve sketching today and tomorrow until we write the test on Friday. Thursday. Thank you. All right. Know how to do vertical asymptotes. That's more important. Okay? All right, let's just do a curve sketching question because I know he did one today. So all right, here's our question. Curve sketching. Okay, I want to sketch this curve. Y is equal to x plus 2 over x. I want to know x-intercepts, y-intercepts, horizontal and vertical asymptotes. All right. So horizontal asymptote, vertical asymptote. Okay. What's the vertical asymptote? 0. Whatever makes the denominator 0. So x is equal to 0. What's the horizontal? 1, right? So what's the degree of the top? 1. What's the degree of the bottom? 1. So it's the second rule here. Okay? So it's just y is equal to 1. All right. X, Y intercepts. We haven't done these in a while. How do you find the y-intercept? Make x equal to 0, right? So if I'm going to do the y, that's when x is 0. If I put x is equal to 0 into there, what do I get? You're going to get this, right? Can you do that? No. So is there a y-intercept? No. So there's no y-intercept. All right. X-intercept. How do you find those? Okay, but how do you find them? Make y 0. So if I make y 0, so this is like one of the questions you did on the stuff I gave you yesterday. How do you solve this? You can multiply the x up to the other side, okay, which essentially makes it go away, right? So that's what 0 is equal to x plus 2. So my answer is -2. Okay. We've got our vertical, we've got our horizontal, we got our x, and we got the fact that there's no y-intercept. We have a bunch of information. We haven't even done calculus yet. Okay? So you've gotten probably 2 marks for not even doing calculus. All right. So now we have to do the calculus. So this is the graph going up, graph going down stuff that we did earlier today. All right. So what is the very first step every time? If you don't know what to do, you derive it. So what rule are we going to use here? Quotient? No. It doesn't matter. I'm going to use quotient, but you can use product if you flip it up. Or you can divide it off, right? So there's like 3 ways to do this question. You can go quotient rule. You could rewrite it like this and do product rule. Or, is there another one? You can move the x to each one, right? You could rewrite it like x over x plus 2 over x. What's x over x? And the 2 over x will become 2 times x to the -1. Okay, so let's do the derivative of that one because that's probably going to be the easiest. So what's the derivative of this? Yeah, so the derivative of 1 is 0. The derivative of 2x to the -1 is -2x to the -2. So you'll get a mark for doing the derivative. Okay, so we've got 3 marks right now. Okay, if you see a negative exponent, what does that mean? How do you make it positive? Flip it to the bottom. So I'm going to rewrite it like this. Okay, that's a little easier to see. Now, he talked about critical numbers today, right? What is a critical number? What does it do to the derivative, though? 0 or infinite or undefined. Okay, so critical numbers let's say equal when f prime of x is 0 or undefined. You can have both, yeah. We'll do one that has both. All right. So 0 is the only one, right? Because if I put 0 in there, I get an undefined value. So we have, therefore, critical number at x equals 0. Okay. All right. What did he say to do once you have your critical number? Or numbers, sorry? You do the table, right? Does that agree with everybody? Okay. He does his tables different than I do. I asked him, you can do it my way, you can do it his way. It's up to you. Yeah, but mine's not really a table. So I showed him mine, and he's like, yeah, that's fine. I draw a number line, and I put my critical number on it. Okay. And then you just test a point on either side of the critical number. Okay. So I go, okay, first derivative. I want to test a number to the left of 0. It doesn't matter what number you test. You could test -4 billion if you really want to. You might as well test the easy ones. So what would be the easiest one? -1, right? And you put the critical number into the, or you put the interval point that you're testing into the derivative. Okay? So I'll just pick -1. So plug -1 into the derivative. So if you do that, what do I get? I get -2, right? Because -1 squared is 1. So it's negative. Go away. It's -2. Now, I don't care what the number is. I don't care if it's -2, -5, -8, -1 billion. What do I care about? That it's negative, right? Because we're talking about the derivative being negative. What does it mean if the derivative is negative? What does that mean the slope is? It means the slope is negative, so the slope's going down, right? So the graph is going down, I should say. So that means the graph is decreasing. This is not the graph, this is my table. So I write f prime of x is negative on this interval, which means the graph is decreasing. Okay? Then you have to test the point on the other side, on this interval here. What would be the easiest point to test? 1. So test 1. And you don't have to write this stuff out. Like you can do this in your head quickly to tell me if it's positive or negative. So I get -2 over 1 squared gives me negative. So what is the graph doing? It's going down. It's still decreasing. So the graph is decreasing over the entire domain. Okay? So we're going to sketch this graph now. Is everybody with me so far? Yeah. Yeah, we'll talk about that in a sec when we do a more complex one. Sorry? Oh, sorry, that's my negative. So really it's like negative of, because the minus would mean negative. But I don't know why I just do that. Sorry. All right, so the graph. We have, mark everything on the graph. We have a y-intercept that does not exist. We have an x-intercept of -2. We have a horizontal asymptote of 1 and a vertical asymptote of 0. So mark all those points. So vertical of 0. We got the dashed line going through here. The horizontal of 1. We have an x-intercept of -2. All right. Now you could do this graph without, this is a graph that we did in Math 12. You don't even need calculus to do this. But we know that the graph is decreasing from -infinity all the way up to 0. And it has to go through this point. So what does it look like? Yeah, it goes like that, right? So it looks like this. The only thing you can draw is this. Because you can't pass through the vertical asymptote. Can't go through that. And for us, we're going to say you can't cross the horizontal. I know, I'm going to do one that doesn't have one as well. Yeah. So does that match up with this, that our derivative is negative? Is the graph decreasing on that interval? Yeah, it's still going down. Okay. Now, let's do the second bit. We're still going down. So how am I going to draw the graph from 0 to infinity on this side? Where's it going to be? It has to be decreasing, so you can't go like this. Yeah. So if you start up here, the graph is still decreasing, right? I don't know what you mean. Sorry? That's got symmetry. I wouldn't say it. Yeah, you just say it has symmetry. So this is still decreasing. All right. It's just on this side of it. All right. You couldn't have drawn it like this. Like you couldn't have gone like that because it's going to cross that horizontal there, right? So you can't draw that. The only way you could draw it is like that. Yes.
So if we tested another point and we got another answer besides -2, that would also be a point.
If you tested like 3 out here, it should give you a negative. If I put 3 into here, I would get -2 over 3 squared, which is -2 over 9. Still negative, right? That's all that matters. I don't care that it's -2 over 9. All I care about is the sign.
Okay.
Okay? No, because the derivative is negative. What does the derivative represent? The slope, right? The slope of that second part is still negative, right? If the derivative is negative, it means the graph is going down. Okay, now, he's going to do this tomorrow, so I want to teach it to you right now. We'll do the same graph. What we're going to do is we're going to take our derivative, f prime of x. There's our derivative. We're going to do the second derivative. We're going to take the derivative again. Okay? What's the second derivative? There you go. 4x to the -3, which means 4 over x cubed. All right. I want you to test x is equal to -1 and x is equal to 1 in the second derivative and tell me the sign that you get. That's all I care about is the sign. Is that what you got? Negatives and positives? All right. Let's look at the graph here. This is the next thing he's going to teach you. When your second derivative is negative, okay? The second derivative talks about the curvature of the graph, how it's curving. Your graph is concave down. You guys know what concave and convex mean? All right. So concave is curving down, like that's concave down. I'm not going to say convex. I'm just going to say concave up. Okay. That's concave up. All right. So it's the curvature of the graph. So when your second derivative is negative, the graph is concave down, the graph is curving down. When the second derivative is positive, it's concave up. So even though the graph is decreasing, its curve is up. It's facing up. It's like a lens or a bowl. Think of it as a bowl, right? The bowl would be facing up, whereas this, the bowl is upside down. Okay? I know. So, if f double prime of x equals negative, down, and it looks like that. If f double prime of x is positive, concave up. The f double prime, you mean? Yeah. You test a point on your intervals. All right. We're gonna do a practice one here in a sec. Okay. When f double prime of x equals 0, this is called a possible point of inflection. We're going to call them PPOIs. Possible is 2 S's. Why did I blank on that? So that's just going to be abbreviated PPOI. All right, we're going to practice this again. Okay. So here's our function. Sketch y is equal to, we'll do a polynomial. 3x to the fourth minus 6x squared. All right, I'm just going to tell you the x-intercepts and y-intercepts, okay? X-intercepts are 0 and plus minus root 2, and the y-intercept is 0. All right. What's the first step? Derive it. It's a oh, sorry. Ask yourself, are there any asymptotes for this graph? How do you know? There's nothing in the denominator, right? There's no variable in the denominator. So you know there's no asymptotes. All right, so first step, y primed. What's y primed? Okay. Okay, so once you have the first derivative, what do you find? Critical numbers, okay? So find your crits. How do you find your critical numbers? Set it to 0. So you just go 12x cubed minus 12x is equal to 0, and you solve it. Factor out of 12x. Okay? And I get x squared minus 1 is equal to 0. So what are my critical numbers here? 0, 1, and positive 1. So does everybody understand that? All right, those are your crits. You're going to get a mark for that. You're going to get a mark for the derivative. You're going to probably get a mark for finding your crits. All right? Then we need to find the second derivative. Get a mark for doing this. What's the second derivative? (36x squared minus 12). Yeah. Because he's running out of time. He's going to do it tomorrow. Yeah, you'll have to do it. That's why I'm showing it you now, so you get more time practicing it. Okay. So now, once you have your second derivative, it's just like the critical numbers, except they don't call them the critical numbers because critical numbers are to find your maxes and mins. You are finding the points of inflection, essentially the curvature of the graph. So all you do is you set the second derivative equal to 0, the same way you did for the first derivative. Okay, so I just find your PPOI. And doing that, all you do is you go 36x squared minus 12 is equal to 0. How do you solve that? You can factor out, or you can move the 12 over and divide by 36. It doesn't really matter. Okay, so you can go you divide off 36, you get 1/3. What do I do then? Square root it. Yes. So x is equal to, when you square root something, you get positive and negative. So it's plus minus 1 over root 3. Those are your PPOIs. So let's look at this. You've got, I would say, 1 mark for the first derivative, 1 mark for the second derivative, 1 mark for the criticals, 1 mark for the possible points of inflection. You got 4 marks out of, I think it's 9 or 10, whatever the question's worth. Okay? Well, you can square root the 1, but that's just 1. That's fine. Yeah, that's totally fine. All right. And you can write the decimal too. Okay, so you got 4 marks out of 9. 10 or whatever the question's out of. You're almost halfway there. So now we have to do the table. All right? These questions are long. So now you draw your number line. On the number line, you have to put all your critical numbers and all your possible points of inflection. Okay? So critical numbers I'll do in black. 0, 1, and -1. Those are my critical numbers. The possible points of inflection we'll do in green are plus minus 1 over root 3, which are going to be in here. Which is like 0.57. I'll put the decimal right below it. For those of you that like decimals. I'll show you what you do on a graph. You just label everything. Okay, so now we test points, okay? But this is the trick here. You only test the points you need to test, all right, in each derivative. So we'll do the first derivative first. F prime of x. Okay. All the first derivative stuff is in black. So I have to test a point on this side of -1. What would be the -2? Where do you put it? Into the first derivative, right? It says right there. So you put -2 into the first derivative. You can write it out. We might as well just write it out. So if I go f prime of -2. This is our derivative right here. Is that going to be positive or negative? Negative. That's all I care about. I don't care what the number is, just that it's negative. Does everybody understand how that's going to be negative? All right, so I just write negative. What does that mean if the derivative is negative? It's going down. Okay, we're still testing the first derivative. My next interval, remember we're only doing the black ones, ignore the green, is between -1 and 0. What would be a nice number to pick? -0.5 or a half. I'm just going to tell you what it is, okay? So if I did this, you're going to get positive. So on that interval, we are positive, we are going up. What's my next interval? Sorry? Positive 0.5. It's right in here, this bit right in here. So if I go f of 0.5, I get negative. They don't always alternate like this, but yes, thank you, f prime. And then I go f prime of a number greater than 1, so we'll do 2, which is positive, which means we are increasing. Okay, that's the first derivative stuff. The second derivative stuff, what are my intervals? We're only looking at the green. It's from here to -infinity, so what would be a nice one to pick? -1, you can pull that, right? So I can go f double prime of -1. I will tell you that that is positive. So what does that mean if the second derivative, so down here I write second derivative, this is my interval that I'm testing. If the second derivative is positive, what does that mean? It's concave up, okay? So that means it's a positive and it's concave up. Then I have to test this from between these 2 points. What would be the easiest number in the world to test? 0. If you put 0 into the second derivative, what do I get? Negative number, negative 12, right? So that means it's what? Concave down. So the graph is curving down. And then you test on the other side of 1 over root 3. What would be the easiest number? 1. What do you get? Positive. Negative f double prime of 1. I get positive. So it's concave up. Okay. This stuff? No. All you have to know is if it's positive or negative. You can just, like this one, you can just look at it and go, oh, it's going to be negative 12. If you do it in your head, Torsten doesn't care about that either. Okay? All right, now we can sketch the graph with all our lovely information. So, all right. Mark out your x-intercepts, which I've given you. 0 plus and minus root 2. So 0. And then negative root 2, positive root 2. Mark your critical numbers, which are 0 and plus minus 1. So 0 is already marked. Plus minus 1. And mark your possible points of inflection. Y-intercept was 0 too. But you would mark that, yeah. Points of inflection are plus minus root 3. 1 over root 3. Okay. See, these are long questions, right? There's so much information. And then the final step. Sorry, let's continue the marking. You're going to get a mark for your table. Maybe 2, I don't know. So we're either at 5 or 6 marks now. And then you're going to get a mark for the graph. Okay? Here we go. So look at the table. The table says from way out here to negative 1, what is the graph doing? It's going down. It has to go through this point. This is an x-intercept. Okay. Has to go down, and is it concave up or concave down on that interval? Concave up. So when it's coming down, it's still sort of swooping like that. Okay? So as it comes down, it's coming down like this. Okay. At negative 1, you stop it when you get to negative 1, because what happens at negative 1? It switches to going up, right? It's still concave up though, right? So it's still concave up, so it comes up, swoops up. Now we have to stop at this negative 1 over root 3. Because what happens at this point? What happens to the curvature of the graph? It switches from curving up to curving down, but it's still going up, right? Does that make sense to everybody? So it's going, because and then it switches. It's hard to show it. What I would do right there is I would say POI, point of inflection. Okay, it's hard to show the curvature of a graph when you're drawing it, especially when you're drawing it in segments like this. Okay, at 0, what happens to the graph now? It starts to decrease again, but what's the curvature? It's concave down still, right? What happens at 1 over root 3? So the graph switches from being concave down to being concave up, but we're still going down all the way till we get to 1. I think this is a horrible drawing of a graph. It's abstract. And then at 1, it starts to increase again, and it goes through root 2. And that's your graph. So these 2 points, the points of inflection, mark them as POIs, just to be clear, so everybody knows where are your maxes and mins. You can see them clearly when you look at the graph now, right? There's your max. There's your min. There's your min. And those correlate with the table because when you switch from decreasing to increasing, you get a min. When you switch from increasing to decreasing, you get a max. I know that was a lie. He's going to ask you to do this on the test. Okay? Do you want me to summarize what to do? Want to list the steps? Sorry? That's this. This is my... It'll look... Your question will look like this on the test. Like... I don't understand what you're saying, actually. Okay. All right. Let's summarize the steps, and then we're done. And I'll give you... I have a sheet here for one question to do tonight. All right. Steps for curve sketching. All right. What's the first step? Derive. Find f prime of x. What's the second step? You could do that first or second, but once you find f prime, let's stay along those lines first. Once you find f prime, what do you want to do? I would say find the crits and then do f double prime. But so find the crits, which is when f prime of x equals 0. And you're right, you don't have to do it like exactly in this order. You could just find all your derivatives and then set them equal to 0. Third step. Find f double primed. Once you find that, you should find your PPOI, possible points of inflection. By setting the second derivative equal to 0. There you go. Now that could be the very first thing you do as well, right? But these are all the things you have to do. X you do it with the original. So the x, y-intercepts and the asymptotes, you can do all that right at the beginning if you want, or you can save it to the end. Some people do it at the end, some people do it at the beginning. So it's up to you. I'll look at your test. I'm not sure if you have to. Okay. I have a feeling he probably won't because it's just time, really, right? I have a feeling he's probably going to give you a polynomial-esque type like these. X, y-intercepts. I'll just say asymptotes, if any. All right, once you find all that stuff, then what do you do? test points, i.e. you do the table thing. Either his table or my table or invent another table. I'll just say test points in table. And then the final step, graph it. They're long questions. They take like a page to do. There's part marks all over the place. Don't leave anything blank. If you don't know what to do the derivative, do the second derivative. Find your critical numbers, find your possible points of inflection. You should be able to do that. All right, this is one from an old class. It's from an old quiz. I'm going to give you the second derivative. I'm going to write it on the board right now, just because I think you should practice it, but the second derivative gets a little hairy. Okay. You won't get one that is as tough as this on your test. Okay. I think 45 minutes. That's why he's not going to give you a crazy. There's only 3 derivatives though, right? 3 derivatives. A higher order derivative question. And then curve sketching.
Are you watching it?
Small, it's not like a big pie.
Yeah.